is lesson 14, 15, 16, a solving systems by elimination lesson. Basically, you are either watching this after I've taught this lesson or prior to front load any information. So again, we've been looking at solving a system by graphing, solving a system by substituting, and then this is the final push, and we're going to be looking to solve a system by eliminating. So let's go ahead and look at the first couple of slides here as our warm-up. So this is a Notice and Wonder slide, and I'd like you to take a look at these four systems. So we have system number 1, here's another one, number 2, number 3, and number 4. So I just want you to take a look, and what do you notice and wonder? I'd like you to think of 5 or notice 5 things or wonder 5 things about these systems. Okay, so there's lots of things that I'm hoping that you may have noticed. I'm going to point out what I noticed. I noticed that I've got a 0, a 0, a 0, and a 0 on every single equation. I also noticed that in equation 1, I have only x, and in equation 2, I have only y, and in equation 3, only x, and in equation 4, only y. So that's interesting. I also noticed that this middle part right here, plus 4y, minus 3y, plus 3y, minus 6x, plus 6x, 4x, minus 4, those created zeros. I also noticed that these were all added. All of these systems were added. So that's what I noticed about these. I also noticed that I would easily be able to figure out what x was and what x was for 1 and 3, and what y was for 2, and what y was for number 4. So those were my notices. I wonder what these represent, but I really was concentrating on just noticing something. All right, moving on and looking at the next slide. Oh, remember these? Remember how we looked at balancing? Well, one of the things I'm noticing here is that I have no idea what these are balancing to, right? I have no values, but I want you to take a moment and I want you to notice some things about these balancing mobiles and see if you can jot anything down. So one of the things that I noticed is that these are all balanced, okay? And that means that somehow these values are going to be the same. The other thing I noticed is that if I take this balance or mobile and this mobile, and I add them together, I get this and this. So take a look. On the left-hand side, I have 2 circles and 1 more, gives me 3 circles. I have 1 green triangle, 1 green triangle. And notice on the very last one, I have a blue square and a yellow pentagon, and I added those together. So now I wonder if I add those together, would they still be balanced? Of course they would, right? Because take a look, they're showing balanced on that mobile. So let's go on and take a look at this next slide. So now we are going to be looking at solving a system that Diego is doing, and we're going to be looking at his work in detail. And I want you to notice, what did he do to solve the system? So we started here, and then here's his work. And notice that he got y is equal to 2. And then once he found out what the y was, it looks like he used substitution, right? So what do we notice? Well, I want you to think back to our warm-up at the beginning. We talked about if I have 4x and I take 4x away, look what I got. I got 0. And when I have 3y and I add 5y, I get 8y. And when I take 10 and 16 and add those two together, 10 and 6, I get 16. And then I found out that if 8y is equal to 16, well, that y is equal to 2. And how did he get that? He divided both sides by 8. All right, so what did he do to solve the system? He added these two equations. He added them together, and then he used substitution. Once he found the value of y, he used substitution to figure out what x was. So go ahead and let's type that into this box right here. So you could see I substituted and I wrote into the text box that Diego added the two equations together to eliminate or get rid of one of the variables. And which variable did he eliminate? He eliminated x, as you could see right here. Oops. That you could see right here. All right. So then what did he do after that? He found out what the value of y was. Found out that y was equal to 2. And then he used that value back in. He used substitution then to find the value of x. So we can do that. We can simply add down to eliminate a variable. That's a pretty cool thing to do. All right, let's go on and look at this one. Is the pair of values that Diego found actually a solution to the system? So what you're going to do is you're going to select your answer choice below, and then we're going to verify by showing our work on the sketch pad. So let's take a look. So I'm going to assume that yes, it is correct, all right? And now we're going to verify it, all right? How are we going to verify it? We're going to verify it by showing it on the sketch pad that is part of this slide. So what does that mean when I ask you to verify? Well, we know we have a value for x and y, so I'm going to write that as an ordered pair. Remember, our solutions are always written as ordered pairs. And we have our original equations. Remember that? So I'm going to go back up, and I am going to get this system right here. And I'm going to substitute in this x and y to verify that my equation will be true. So look what I do. I'm going to go 4 times 1 plus 3 times 2. And I want to know, does that equal 10? So 4 times 1 is 4 plus 6. Does that equal 10? 4 plus 6 is 10, and 10 is equal to 10. Check. So it works in the first in the first equation. Let's verify the second one. So I'm going to use negative 4x, and I'm going to multiply again by 1, and I'm going to add 5 times 2, and I want to know, does that equal 6? Well, negative 4 times 1 is negative 4, plus 5 times 2 is 10. And does that equal 6? Negative 4 plus 10 is equal to 6. And 6 is indeed equal to 6. So the right and the left are balanced right here. Check, it works. Therefore, my solution of 1, 2 is indeed a solution to the system. So yes, I have now verified it. All right, let's move on and look at the next slide. The next slide asked us, so we're given another system of equations. 2x plus y is equal to 4, and x minus y is equal to 11. Does Diego's method of adding work for solving this system? So let's go ahead and do it. Let's go ahead and add down. So if I have 2x and I add another x, how many x's do I have? I have 3x. And if I have y and I take y away, what do I have? 0. If I have 4 and I add 11, what do I get? 15. So take a look. Was I able to eliminate the variable of y? Absolutely. So yes, I could add the equation in order to solve the system. That's all I needed to do in this situation. All right, let's move on to the next slide. The next slide says, okay, let's look at this one. Does Diego's method of adding work for solving this system? So let's do the exact same thing that we did. We're going to add these two together. If I have 8x and I add 8x, I get 16x. If I have 11y and I add one more y, I have 12y. And when I take 37 and I add 7, I have 44. So take a look. Adding those two together didn't work. No, it did not help me solve this system. I did not eliminate a system, a variable. I didn't eliminate an x, and I sure as heck didn't eliminate a y. So adding these will not work. All right, let's look at this next one. So why did it work for the first one, but not for the second? Why does adding the equations work for solving this system, but it didn't work for this one? So I'd like you to think about that. What were we able to do? So hopefully you figured out that what we were able to do is we were able to eliminate the variable y in the first set. But we were not able to eliminate anything in the second set. So you could see here that I finished up my dialog box, and the whole idea about using elimination is to get rid of a variable. And right here, I would have been able to eliminate y. All right, so now let's move on. And now let's take a look at this. So what would happen if instead of adding, we subtracted? All right, so let's try that. So what I want you to do is we are going to take this whole thing, I'm going to circle it, and we're going to take and we're going to subtract everything above from the top. All right, so let's do it on our sketch pad below. So if I have 8x and I take 8x away, I have 0. And if I have 11y and I take 1y away, remember we're subtracting, what am I left with? I am left with 10y. And what happens when I have 37 and I take 7 away? Remember, we're subtracting. I would get 30. Look at that. So I eliminated this x. Very cool. So what now is our solution to the system? Well, we can continue by solving for y. Whoops. How would I do that? Well, I know that 10y, I know that 10y is equal to 30. Therefore, I can divide both sides by 10 and find out that y is equal to 3. So if y is equal to 3, can I figure out what x is? How can I verify it? Well, I'm going to say that y is equal to 3. So take a look. What can I do? I can substitute this value of y back into either equation. So what would be the easiest equation to do? I would most definitely do it into this equation right here. I could do either one, but I'm going to use the second equation. So take a look what I do. I'm going to substitute the value of y is equal to 3 right here in for that y. So this is what it looks like. 8x plus 3 is equal to 7. I'm going to go ahead and remember what I want to do is I want to find the value of x. So in order for me to do that, I need to subtract 3 from both sides. When I subtract 3 from both sides, I've got that 8x is equal to 4. Now what do? Divide both sides by 8. 8 divided by 8 gives me 1x. Therefore, x is equal to 4 over 8. And I can simplify that by dividing 4 divided by 8, which would be 1/2 or 0.5. So now, what's the solution to our system? So now I know that I have two values. I have the ordered pair of y is equal to 3 and x is equal to 0.5. So 0.5 and 3. So now what do? I want to make sure that if I put in the x value for the x and put the y value in, that these equations are going to work. Okay, so check out what I do. I went into both equations, and I am substituting the x in where I see an x and the y where I see y. All right, so just so you know, and I'm going to go ahead and do the arithmetic, and I want to make sure, does the left side equal 37 and does the left side equal 7 after I substitute? Okay, so this is the piece that students hate to do, and I'm going to insist just in case maybe you make an error. Take a look. 37 is equal to 37 and 7 is equal to 7. All I did was substitute, did the arithmetic, and confirmed it. All right, let's look at this next slide. So now you're given a graph, right? Take a look at the graph. You've got equation 1 and equation 2. What are the coordinates of the solution? Go ahead and put it in. Hopefully, you put in 1, 2. All right? So, take a look. 1, 2. Yippee. All right. So, notice that it gave us our solution right there. All right. So now, whoops. Let's go back up. Now it's asking us, okay, so now you've got your graph, you've got your solution, but I want to take it one step farther. We're going to add and subtract equations to solve this. So here's our equation 1 and equation 2 right here. And I want you to find a new equation that results from adding the two equations together. So go ahead and do that. Okay, so you can see all I did was add straight down. 4x, and if I add a negative 4x, I get 0. I didn't write 0, but I could have, right? 3y and 5 more y is 8y. 10 and 6 is 16. So what you were supposed to do is in this box right here, take this value, put it right here, and you could see here that it is correct. Notice when I did this, look what happened. That if I were to solve, take a look. Take a look what popped up right there. A horizontal, I almost said vertical, a horizontal line. So if I were to actually solve this, what is y equal to? Y is equal to 2. And this is the equation. Remember we did this. Y is equal to 2. So look at the resulting graph. Make an observation about the new equation. Well, I just kind of basically gave it to you. Well, hopefully you noticed that the new equation is a horizontal line, and it also intersected at 1, 2. Interesting. All right, so now, next one. Same exact thing. Graphed is the system. What are the coordinates of the solution? Right here. What is that solution right there? Go ahead and write. So hopefully you wrote 5, -6. Bingo, we are correct. All right, so now, take a look. I want you to take those two equations right up here, and I want you to find the new equation that results from adding the two equations together. Do that right now. So hopefully you can see what I did. I took 2x, added another x, I get 3x. I have y, and I add a negative y to it. What do I get? 0. 4 and 11 is 15. So what is my equation? 3x is equal to 15. So then what you were supposed to do is note what happened. Look at that green line right here. So this 3x plus 15 is that new green line. Make an observation about the new equation. So check this out. So if I were to actually solve 3 times what number equals 15, or what is the value of x equal to? X is equal to 5. Okay, so if I remembered from that review that Ms. Hannaford did back in lesson 13, remember this equation, this green line is x is equal to 5. And that the new equation has a solution of x is equal to 5. And that it intersects at this same point of 5, -6. Wow, what is that? So moving on. So basically what you found out was when you eliminate, you actually get a brand new equation that you could graph if necessary. And that point that you graph will be another point of intersection. Interestingly enough, so now let's just take a look at this slide. So you've got system 1, system 2, system 3. Looking at the systems above, you've learned how to solve a system by graphing, substituting, and eliminating. So what method would you use to solve each system and why? All right, so let's take a look. So I've got system 1. I would definitely use elimination because check this out. I have n and I take n away, and basically, so I would eliminate by adding these two together, right? System 2, substitute. We saw this in lesson 13. Check this out. I know that y is equal to -2x plus 9. So I could go in right here and substitute that right there. Put that value of -2x plus 9 in for y and then solve for x by combining like terms. System 3, I would either graph it just because I'm looking at it going, I don't really see anything where I'm eliminating anything, or I would eliminate by subtracting. So if I took this whole thing away, I would have 5x, take away 5x gives me no x's, right? I could do it that way as well. So if I didn't see it right away by simply subtracting, I would definitely graph it if I had it available to me. All right, so now that's it, right? That's it. I'm hoping now that you've seen all three. We've got graphing, we have substituting, we have eliminating. Hopefully this solidified, and the next piece of the puzzle is you learn one more way to eliminate, but we're going to do that in a separate lesson.